Hello everyone, greetings for the day. Today I'm demonstrating task 3.1p of SIT 210, which was about creating an IFTTT trigger using webhooks, making use of Arduino 33 IoT device. This is the problem statement and the task objective, in which we have just bought a beautiful terrarium for our house, and we are advised to keep the terrarium in 2 hours of sunlight a day. In order to make that happen, we are going to implement a embedded system in which we are going to make use of Arduino Nano 33 IoT board and the LDR sensor. Also, we are going to make use of the IFTTT service, which would be linked with webhooks and Gmail integration, which will allow us to get a notification throughout the day when the sunlight reaches our terrarium and when it leaves it. This will allow us to have the idea of the sunlight, whether it is present or not, remotely without having to visit the terrarium. In this task, we are going to show the hardware setup, the software setup, the code, and the working system and how it actually works. Moving towards our first objective, the hardware setup. Before diving into the code, let's first set up the hardware connections for our LDR sensor with the Arduino board. The LDR sensor, as we know it, is called the light dependent resistor, which works by changing its resistance based on the amount of light that falls on it. We're going to use the same property in order to detect the sunlight in our terrarium. Getting into the connections, the VCC of LDR goes into the 3.3 watt pin on the Arduino. It is because the Arduino Nano 33 IoT board operates on a 3.3 watt logic level. So, keeping everything safe and reliable, we are using 3.3 watt pin. The ground of the LDR gets into the ground of the Arduino, and the out pin of the LDR is connected to A0, which is the analog input pin. Now let's take a look at the cloud integration part. We have set up a cloud variable called sunlight, which is of data type boolean, set up within our code. That's going to help us in detecting whether the sunlight is present or not. Then let's move on to something very crucial for the system, which is the IFTTT integration. We have set up a basic if then applet that says that whenever uh, a web request is received, a mail is sent to our email address that we have attached to this webhook, indicating whether the sunlight is present or not. This happens by making use of the unique key uh, in the webhook documentation in our Arduino IoT Cloud Editor. All these components allow for the system to work. Now coming to the software and the code part. This code is designed to continuously monitor light levels and report significant changes back to the cloud. Instead of sending the data on every loop cycle, it optimizes updates by only reporting them when the sunlight status changes, avoiding unnecessary cloud communication. Now at the start of the program, we have defined initial serial communication, set up Arduino Cloud, and establish a connection to the internet using Arduino 33 IoT's internet connectivity capability. This part is crucial, we would say, because it ensures that the Arduino is properly set up to communicate with Arduino Cloud. Now let's move ahead to the loop function. We can see that we are continuously reading the data from the LDR sensor, which measures the ambient light level. The sensor is connected to the analog pin A0, and the value it reads help us to determine whether the sunlight is present or not. We have set a threshold value to 200, which if the value is detected more than 200, we can say that the sunlight is present, else it would be absent. To make the system more efficient, we don't update the cloud on every loop cycle, as we have discussed before. So we can see if the sunlight reading has changed since the last time we have read it. Now let's move ahead to the cloud integration. One of the most important part we would say is the on sunlight change function. This function is automatically triggered when the sunlight variable in the Arduino cloud is updated. Now let's move towards the video demonstrating the working of the system.